All right, problem set 3.2. It starts on page 179. We're going to go over a few examples together so that you can get your feet wet as far as how to do some of this. 17 through 48 is basically what we did there toward the end. We're just reducing fractions to lowest terms. Let's start with just numbers, and then we'll throw in some letters there toward the end. Does not matter if the number on the top is bigger than the number in the bottom. We're just doing it the same way. So in order to reduce this, we're going to reduce to its prime factors. Prime factors of 36. Well, let's do the factor tree just this once here so you can remember what's happening. So 2. 18 reduces to 2 and 9. Circle that one. And 9 reduces to 3 and 3. Alright, so we have 2 times 2 is 4, times 3 is 12, times 3 is 36. So I got all those correct. 20 then goes 2 times 2 is 4, times 5 is 20. So there's my prime factors. Now I'm going to do my division. 2 over 2 is 1. Get rid of those. 2 over 2 is 1. Get rid of those. And I'm left with 9 over 5. And I'm done with that one. Let's do one with, well, in fact, let's do one with some letters. And I'm going to put a little bit of a twist on this for you. Let's look at number 35. 18a squared b and 90ab. All right. If you remember, your a squared is the same as a times a. So what we're going to do is we're going to write it that way. Whenever you see an exponent, a 2, a 3, an 8, a 15, whatever, up here, we're going to write it out as a times a. If this were a cubed, it would be a times a times a. So let's write the numbers out as well as the letters out. So I'm going to write it below here. 2 times 3 times 3, that's my 18, times a times b. So I got that long line there. 90, let's do the factor tree on the 90. Let's see if you can see that over there on the edge. Yep. Okay, so let's do this. 2 and 45. So we're going to circle that. 45. Okay, let's see. What goes into 45? Well, 5 does. Any number that ends in 0 or 5, 5 goes into. So we can divide 5 into that 9 times. So we'll circle our 5 since that's prime. 9 is not prime, so we're going to reduce that further. Alright, so for 90 we have a 2, we have 2 3's, and we have a 5. We also have an A and a B. So at this point, all we're concerned about looking at is what we have there in that box. So what we're going to do is we're going to do our dividing with numbers that are common to each other. So 2 over 2, 3 over 3, 3 over 3. Oh, and we have an A and an A, so we're going to get rid of those. Oh, and a B and a B. We're going to get rid of those. Which leaves us with an A on top. That's all. We could put a 1 there if you want, because remember when we didn't end up with anything, I said put a 1 up there. We did end up with an A, so we can put the A up there. Even though it's a letter, not a number, it's still something that's going up there. What we have left here is just a 5. So, that being the case, that's all we have left, and we're done with that particular one. So, takes a little bit of room, takes a little bit of time to do each one of these, but it is what it is. It's the method to reduce these. Let's see, I'm trying to look here and see if there's any that might give you a little bit of difficulty. You know, let's look at number 48, 273. We're getting into some bigger numbers. Over 385. Alright, I don't know about you, but I'm going to need a factor tree. There's no way I can do that on my own. So I'm going to look at 273 first and break that down. One of the things that helps to determine if a number goes into, if you have a factor of 273, if it's prime, then you're done. You can't reduce it. But there's really no way on 273 you can just look at it and determine if it's prime. I mean, it kind of looks prime. I can't think of any number that goes into it. But a couple clues for you that'll help you to figure out if there are any factors. First clue is if the number is even, 2 goes into it. If the number ends in a 5 or ends in a 0, like 380, 5 will go into it. Another really good clue is if you take the numbers 273 and if you add them together, 2 plus 7 is 9 plus 3 is 12. If you do that, if you can add up those numbers and you get a number, if 3 will go into the 12, then 3 will go into this whole thing. Okay? So because 3 goes into 12 4 times, 3 will also go into 273 times. We don't know how many, but we know 3 will go into it, which means this is not a prime number, so we can do the factor tree. Whereas 385, 5 goes into it because it ends in 5. Let's see if 3 goes into it. 8, 11, and add 5 to it, you get 16. No, 3 does not go into 16. It goes into 15 and it goes into 18. It does not go into 16, so it will not go into this number. But now that we know that 3 goes into it, we can use 3 as one of our numbers there. So 3 goes into 273. See, I don't even know. I'm just going to have to do the division here, but I know it's going to go evenly. Okay, it goes 91 times. 27, 0, 3, 1. Yeah, it goes 91 times. All right. I do know, though, that 91. Can you think of any number that goes into 91? I can't either. I'm going to check something here because that just doesn't seem. 9 times 7 is 27. Yep, 3 does go into it 91 times. All right, so we have 3 and 91. All right, well, let's try 385. We said earlier that 385, that 5 goes into it. No idea how many times. So let's do the division again. 385 divided by 5. 7, 35, 35, 7. 7 times. So 5 and 77. I know 77 is not prime because 11 will go into it. 11 goes into 22, 33, 44, 55, 66, 77. So it goes into it 7 times. So now I have 5 times 7 times 11. Alright, that being the case, I come up here and think, okay, can I cancel anything? At this point, there's nothing I can cancel. Absolutely nothing. I am stuck with what I've got there. 273 over 385. I don't have a 3 up here, down here, a 5. I'm not seeing nothing. So this would be reduced if I did everything correctly. So 273 over 385. Unless you find something I missed there, we'll just call that good. Looking on page 180, what they're doing here is giving you some things to think through that you're supposed to take what we learned in this lesson so far and been given how they did it. Let's look at number 53A, for example. They give you 5 over 15, and they're reducing that to 5 over 3 times 5. And they cross those out. And they got for an answer then, because of that, 0 over 3. Because we have a 3, we're going to put there, we cross this out, nothing left, so we put a 0 there. And they're asking, what is wrong with that? Well, and you would look at it, if you remember what I said, 0 never goes on top. If there's nothing to go on top because you canceled it, put a 1 there. So, go ahead and get started on that lesson and stay tuned for lesson 3.3.